This is an interesting picture. I really like it, as it reflects all of us, the developers. We are the bravest among all. We are confident as well, as we like to test our code only in production. We are not only the bravest and confident, we are introspective as well, and that's the reason all of you are here to listen to this talk on writing quality code. At the end of this talk, you will have 5 simple but powerful points to take away in your goal towards writing quality code. Let me not bore you with my introduction again. However, I can't skip this slide without stressing upon a point. Coding is my passion. I love coding. Let us look at some of the dictionary definitions for the words which we are going to come across in this talk. First of all, it is quality. It is a logical proposition of being affirmative or negative. In this talk, we are going to concentrate on affirmative part of it. Code is a set of instructions for a computer. Program is a plan towards a goal. Programming is a sequence of operations to be performed by a mechanism. In this case, it is the computer. Let me tell you about programming. Programming is like parenting. If you want to instill the right behaviors in our child and want to make them good citizens, we need to make sure that we do that from their childhood itself. As developers, we like to make fun of quality processes, right? Isn't it? So code review is one of the process which we invariably follow. And once one of my colleagues asked, what will happen if the developer and the reviewer don't possess the right skills? Naturally, the quality will suffer. So I thought of creating this truth table, and you can see that the quality will if both of them possess the right skills. Even if one of them is incompetent, the chances are very high that quality will suffer. Now let us look at one of the metrics which we look at to figure out what is the code quality. We look at the defect density matrix, and defect density is defined as number of defects per kilo lines of code. I was to fix some of the defects in one of the programs, and I figured that the code was not up to the mark. There were a lot of duplications. So I thought of removing these duplications. The code size reduced drastically from 16.5 kilolines of code to 9.3. And without doing any calculations also, we can say that the defect density went up and the number of lines of code went down. Does this mean that the quality has gone down? No. Actually, I have less code to look at and comprehend in fixing all these defects. There is a myth that the code is not seen by the customer. However, the code is seen by the customer indirectly. The product is made up of the code, and the code is not made up of the the product is not made up of the design. It is actually the resultant. The code is resultant of the design which you have. It is like garbage in, garbage out. If you have good design, then only you will have good code. Let me tell you a story. I was working with a small company at Gandhinagar. I used to commute from Ahmedabad to Gandhinagar. While once on the way back, the bus started giving some trouble. As we had a well-experienced driver, however, he didn't know how to fix the problem. So one of my colleagues, VP of marketing, he said, let me see. The VP of marketing, he took over the control from the bus driver. He drove the bus for a few meters. After driving it for the few meters, he got down from the bus, fixed something in the engine, and the bus worked fine after that. What does this imply? It implies that my colleague not only knew the driving, he knew what is one level below or what is under the hood. Wondering how is this applicable in our software development? Let me tell you a couple of my own experiences in this context. One of them is, there is a programming proverb which says that never write self-modifying code. However, I went ahead and wrote self-modifying code. This code I was writing in such a way that whenever I used to check one flag, based on that I used to modify one of the instruction, and that worked fine on 8088 base machine. However, it failed to work on 80286 base machine. And now there was no way for me to figure this out, what is happening. As I stepped through in the debugger, it worked fine. After thinking for a while, I realized that it could be happening because of the prefetch queue size differences between these two processors. 80286 has got 6 bytes of prefetch queue, whereas 8088 has got 4 bytes of prefetch queue. Now this will, the instruction will get modified only after the change is made in the memory, which will not get loaded in case of 80286. Whereas in 8088, the instruction got loaded in the prefetch queue after the change is made. And that was the reason. To verify this understanding, I introduced some NOP statements just before the instruction I was modifying. And to be specific, I introduced 6 NOP statements. This made sure that the instruction, you will get the modified instruction after the change is made, and it worked fine. In this case, my understanding of microprocessor architecture helped me in solving the problem in assembly language. Similarly, in another experience, I wrote some C program that worked fine in the debug mode of compilation. However, it failed in release mode of the compilation. As I looked into this, and I realized that what could be happening, because I had no way to figure out what is happening if I run through in the debug mode. Now, as I thought over it, and then I generated assembly output. As I generated the assembly output, I looked at the part where it was giving the problem. For one of the expression, whatever the code generated was wrong. As all of us know that the compiler optimization will kick in case of release mode, and that made the difference. There was a bug in the optimizing the code. When I changed the expression with multiple statements, it worked fine in both the modes. What does this imply? My assembly language understanding helped me in solving this C problem. Now, you'll be wondering, or rather thinking, that how is this applicable, as most of us work with Java or JavaScript or modern languages. In that case, how is this applicable? I would say go by the same logic. You know one level below and you'll be better off. If you're working on Java and if you know how the JVM works, you'll be better off with your code. Similarly, if you're working on JavaScript, Node.js, if you know how the event loop works, you'll be better off. Look at this geek. He doesn't want to do the repetitive task on his own. He assigns that to the computer. Do we do so all the time in our code? Maybe, sometimes not. Look at this example. I came across this code while reviewing, and in this code, the developer is trying to write a state selector in a dynamically generated HTML page. He has repeated this statement 31 times. He could have easily done so using a simple for loop. Now, with this, the advantage you will have is, based on the month, selected month, you can make sure that the user does not enter 31. You can change the variable value and you will be better off. So this way, the code is extensible, maintainable, and you will have programming pride as well. As we know that when we take any picture using camera, whatever we see in the viewfinder, we'll have that much only in the picture. Similarly, screen is the viewfinder for our code. Our method or the function should not exceed that. Let us look at this through this example. In this example, you can see that for a single method, you'll have to scroll down to the next screen to look at what is happening. In the next screen, when you go, you realize that there are multiple for loops and that nested ones. So it would be difficult for you to understand what is happening. You'll have to scroll up and down to understand this code. You'll be better off if you make this code in a single screen. I really like this statement by Martin Fowler. He says that good programmers write the code which can be understood by the humans. And as we need to maintain the code, better we write the code which we can understand. I think you would have already guessed the title for this slide. Don't state the obvious. Do we do so? Sometimes not. Look at this code. Are the comments doing any good to the code or any value addition into the code? No. Similarly, look at this. There is a code fragment which has been commented, and on top of that, it says that following code has been commented. I call these kind of comments as divide by 2 comments. Yes, in assembly language, I came across something like this. You can write readable code with less comments, and you will have less comments on your code. Look at this, how we can do that. You should know your problem domain well. If you know the problem domain well, you will be choosing the variable names which are much more meaningful in the problem you are solving, and because of that, your code looks much more readable. It reads like a story. Similarly, normal conditions should be following the error conditions. That means you should handle the error conditions first before you handle the normal conditions. That makes sure that with this habit, you will have advantage of, like, you don't forget the error scenarios in your code. And even if your fellow developer, when he looks at the code, he will also understand that you have handled the error conditions. In a hurry, sometimes we write the code which may not be as we desire. And that's when you should think of refactoring this code. As Martin Fowler says, refactoring is improving design of your code. You should remove the clutter. We should not keep unused code hanging around, because those are the distractions in your code. If you know more than one language, you'll be better off, because you can use language constructs from one language to another, and your code will improve. You should make sure that you write the comments only for document purposes, or if there is a complex logic. However, you should make sure that you make your code readable using the proper variable names and all these things. Otherwise, your comments may become stale. With this, you can make sure that you have less comments in readable code. Look at with this example. In this example, the developer is trying to write a copy function, handling copy button with this JavaScript function. In this, we can see that the variable names are arbitrarily chosen. Even for the operation to be performed, it uses 2 different flags, and it toggles the flag based on the operation to be performed. Now, our fictitious developer is being asked by the reviewer that make this code readable. So he adds the comments to this code. I don't think it does any improvement in this code. Now, look at this, the change code in which the variable names are chosen properly, and even for the operation, you can easily say that now operation which is to be performed is copy operation. So let us summarize what we learned. Know one level below. Be a geek. Remember viewfinder. Don't state the obvious. Less comments and in readable code. I'll be happy to answer any questions if you have.
So I do have a question. You know, one of the things we face is it's good to write quality code. Definitely, we want to write quality code. But oftentimes, it seems to be in conflict with, we got to deliver it yesterday. We don't have time for this. So how would you help us, the programmers down in the trenches, deal with these conflicting goals in front of us? Develop quality, but deliver it fast as well.
Yeah, I think you know this is really a tough question which you asked, and what some of the practices which we need to follow, and if you follow all these things, probably if you go back to the fundamentals, and if you know your fundamentals well, and at that time you'll be able to create the code which is of better quality. Right, and at the same time, you're right. Like we are in conflicting, but at the same time, when we look at the refactoring part of it, and we will be able to refactor our code, and that will help us. I hope I answer your question.
So one part of this, the question that he asked, I believe can be addressed by using code quality tools, plugging them into your IDE, and they will take care of some of these basic things. They can warn you here. Right. But despite that, there's some subjective element to this, which is a feel factor of code. Even if those code tools don't tell you the full story, you just by looking at the code, you realize whether it's well written, it's maintainable or not. So it needs to be a combination of both. So some of those basic things, variable naming or size of comments, size of methods, they can easily be addressed by installing those plugins, and they can be installed in your IDE as well as in your build tool. So that can help you to some extent. And in addition, you just need to develop an instinct for good quality code is what I feel.
Yeah.
Your views on that.
Yeah, thank you.
I basically want to know, how do you define quality code? Because there is actually no particular definition. As a JavaScript developer, most of the time I'm looking at obfuscated code, and there's no way to figure out head and tail of it, So
yeah, so some of the elements which we have looked at, right? And one of the point which Martin Fowler himself said, like code which is readable by humans. So if you write the readable code, and that's where all the modern languages are helping us, like the Scala and all. In JavaScript, I see the timeout sign there. Yeah, sorry. We'll take it offline.